So acceleration in physics is defined as the rate of change of velocity of a body, which means how does the velocity changes with respect to time. If an object is accelerated in the direction of its moving, then it is said to be a positive acceleration. If the acceleration or the body speeds up in the direction of its motion, then we can say that it is a positive acceleration. Hello everyone, welcome to session 2 of chapter 3, Motion in a Straight Line. This is Swati, Faculty of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have discussed about the definition, the meaning of motion. What is motion? How does the position of an object which is in motion or at rest is plotted? What is a frame of reference? What are the different types of motion like uniform motion or motion in a straight line, one-dimensional motion, two-dimensional motion, and the concepts of speed and velocity, the major differences between speed and velocity, and also we have discussed about the concepts of distance and displacement and the differences between distance and displacement in the last class. We even discussed about what is average velocity. Average means taking mean of all the velocities. What is average acceleration, what is instantaneous speed and velocity, and many more things. So in today's session, we are discussing about the acceleration. What is acceleration? How it is defined? We all know about accelerators in our automobiles. Yes, when we have an idea about accelerator, it is important and it is very easy to understand the meaning of acceleration. So acceleration in physics is defined as the rate of change of velocity of a body, which means how does the velocity changes with respect to time. The formula for acceleration is the change in velocity divided by time taken, or it is increase in velocity divided by time taken. So it is nothing but the velocity per unit time, or how does the velocity varies with time. As the time increases, what is the change in velocity we can observe is nothing but acceleration. Acceleration has both magnitude and direction, and it is a vector quantity. The SI unit of acceleration is meter per second square. Because we know the velocity is SI unit is meter per second and the unit of time is seconds. Again, take this to numerator and you will get meter per second into per second, which is nothing but meter per second square. So it is very important. The SI unit of acceleration is meter per second square. So acceleration is given by the formula v2 minus v1 divided by t. What is v2 minus v1? v2 is the final velocity of a body which is in motion, and v1 is the initial velocity of a body, and t is time taken by a body. So here v2 minus v1 is nothing but the final velocity minus initial velocity divided by, so if you take the difference between these two quantities, that is v2 minus v1, we will come to know what is the change in velocity, and divided by t is nothing but the time taken, which is nothing but acceleration. Acceleration is nothing but the rate of change of velocity. So it is a vector quantity, it has both magnitude and a direction. It is said to be a positive acceleration sometimes and negative acceleration sometimes. When it is said to be a positive acceleration, if an object is accelerated in the direction of its moving, then it is said to be a positive acceleration. So what is negative acceleration then? Negative acceleration is nothing but which accelerates in the opposite direction of its movement. So when the body accelerates in its opposite direction, the body will slow down its speed. The speed of the object which is moving will slow down. For example, while riding a brake, when we apply brakes, it will slow down the vehicle. So that is negative acceleration. See here, positive acceleration of a body is nothing but the body which is in motion that accelerates in its own direction of motion. If it is accelerated in the opposite direction, then it is said to be a negative acceleration. So now we came to know what is acceleration. So let us understand what is uniform acceleration. In the last session, we have discussed about uniform speed and uniform velocity. Let us now discuss what is uniform acceleration. So it is nothing but if the velocity of a body changes by equal amount in equal interval of time. We know acceleration is change in velocity divided by time. So if the velocity of a body is changing equally in equal interval of time, we say that it is under uniform acceleration. For example, for 1 hour, the body is changing its velocity for certain meter per second, and next 1 hour, the same amount of velocity is changing. The next 1 hour, it is changing with the same velocity. Then we can say that equal interval of time, that is 1 hour, 1 hour, 1 hour, and the body is also covering equal velocity. So the body is also changing its velocity in equal number. So this case is called as uniform acceleration. I repeat, uniform acceleration is nothing but the change in velocity of a body equally in equal interval of time. So let us see this example to understand uniform acceleration motion. So here the car is moving. Initially it was at 0 meter per second. The velocity of a car was at 0 meter per second, and after 1 second, the time taken by a car to complete this distance, that is to reach 1 meter per second. So it takes 1 second. So in 1 second, the car reaches the velocity of 1 meter per second. In next 1 second, the car reaches the velocity of 2 meter per second. Here you can take the difference. 2 minus 1 is 1 again, which means it is changing its velocity equally in equal interval of time. So this type of the change in velocity in the regular interval of time is called as uniform acceleration. It is important to know about certain terms like uniform acceleration, instantaneous acceleration, and average acceleration in understanding the concepts of motion of a body. So let us now understand what is average acceleration. We all know what is average or how to take the average. Yes, it is nothing but the ratio of the change in velocity to the time interval. So change in velocity by time interval is nothing but acceleration. What is average acceleration? Average acceleration is given by A bar, which is equal to V2 minus V1 divided by T2 minus T1, or delta V divided by delta T. So delta V is nothing but the change in velocities and delta T is change in time. So average acceleration is taking the average of the acceleration where the body experienced in changing its velocity. Instantaneous acceleration. Instant, which means at that particular time. So what is instantaneous acceleration? How can we define it? It is the limit of average acceleration. So average acceleration is given by delta x divided by delta t. We have studied that in the previous slide. So it is nothing but the limit of average acceleration as the time delta t tends to 0, which means the time interval here is very short. So as the time delta t tends to 0, the limit of average acceleration is called as instantaneous acceleration. We have just understood what is positive acceleration, what is negative acceleration. So let us now see what is retardation, why it is called so. So retardation of a particle is defined as the rate of decrease in its velocity. If the velocity of a body which is in motion decreases with respect to time, then we will call it as retardation. So here with respect to time we are talking about, so the rate of change of some quantity means the quantity is varying with respect to time. So retardation is the velocity here is decreasing as the time passes. So the rate of change of velocity means velocity is changing with respect to time, and that is called as retardation. So let us move on to a very important concept, that is position time graph. Now we know what is motion, what is displacement. It's all nothing but the position is changing. If the body is said to be in motion, it is changing its position with respect to time and surrounding. So we know the concept of position and time. Let us now study the value of this position time graph. What is its significance? Why the position time graph is important? So the graph of position versus time is known as position time graph. You can see here, this is a graph where I am varying time along x-axis and position is varied along y-axis. So plotting the position of an object which is under motion with time gives us the graphical representation of how does the body changes its position with respect to time. And this plot of position of an object with respect to time is called as position time graph. So here this graph, the slope under position time graph gives us velocity. So when you draw a position time graph and if you calculate the value of slope, that value is nothing but the velocity of a body. That is the important term which we can understand in position time graph, where we can find velocity by plotting the position of an object which is in motion. So the slope of position time graph, or generally it is called as xt graph or pt graph, gives us velocity. How can we find the velocity of a body with the help of its position and time? By plotting pt graph and calculating the slope of a graph, we can get the value of velocity. Now let us see the various cases of position time graph. How it is plotted when the object is at rest. How the position time graph can be plotted when the object is in uniform motion. So let us see that now. Here you can observe, as I explained the previous slide, along x-axis time is varying, along y-axis the position of the object is varying. So here it says that the position, how does it vary? As the time varies. So here we can observe the body is not changing its position. It is constant throughout, which means the body is not changing its position. If the body is not changing its position, if it is changing its position, then we can say the body is in motion. If the body is not changing its position, then we can say that the body is completely at rest. So here this graph says that a particle is at rest, since the position of the object or the body what we considered is not at all varying. So next case, let us see. Here this is uniform positive velocity. I told you position time graph helps us in understanding the velocity concept as well. So here the position of the object is varying uniformly with respect to time. So this graph says that uniform positive velocity. So next case we have is uniform negative velocity. Here the direction is in opposite direction. So we can say that the uniform negative velocity of a particle is plotted, is represented with the help of this graph. Next we have positive acceleration. The rate of change of velocity is acceleration, and this curve says how does the body is having its positive acceleration. So acceleration is of two types, positive acceleration and negative acceleration. If the acceleration or the body speeds up in the direction of its motion, then we can say that it is a positive acceleration. And the converse of this is a negative acceleration, where the body slows down its speed when it is moving in the opposite direction, and it is negative acceleration. The graph of position time variation for negative acceleration particle is given by this graph. So next we have uniform retardation. So what is retardation? The decrease in velocity with respect to time. We can observe it is getting decreased as the time passes. So we can say that it is uniform retardation. So next, this is about the position time graph. Using this concept, we are going to derive so many derivations in our upcoming sessions. So before that, let us now see what is velocity time graph. So VT graph, generally it is called as VT graph. You can observe here in the previous PT graph or the position time graph, along y-axis we were varying the position of an object. But in VT graph, along y-axis the velocity is getting varied, and along x-axis time is varying. So the graph or the plot versus velocity and time for a moving object is called as velocity time graph. The graph of velocity versus time is called as VT graph or velocity time graph. The slope of velocity time graph gives acceleration. The slope of position time graph gives velocity. The slope of velocity time graph gives us acceleration. So it is the significance of velocity time graph. What do we get by plotting the slope of velocity time graph? It is acceleration. So area under VT graph gives displacement. You can see here the area. This is a VT graph. This is the area under this VT graph. It gives us displacement. But if you calculate the slope of VT graph, it gives us acceleration. Next, what are the uses of VT graph? Why do we have to plot? What we can understand with the help of VT graph. So VT graph represents the nature of motion of a particle. How is the particle is moving? Graphical representations always helps us in understanding the behavior of the motion of a particle in case of the study of the mechanics. Yes, VT graph represents the nature of motion of a particle. Instantaneous velocity and acceleration can be found, which means the velocity at that particular instant of time and what is the acceleration that the body is experiencing can be calculated with the help of VT graph. And also the displacement can be calculated by calculating the area under VT graph. By taking the slope of VT graph, the acceleration can be calculated. By calculating or by analyzing the area of VT graph, we can get the displacement of a particle. So what is displacement? It is nothing but the position changing of a particle. So these are the advantages of VT graph. Now let us see what are the various cases of this VT graph. So what is this negative slope called as? What is the positive slope called as? So let us discuss one by one. If the body is having uniform velocity, then this is the representation. So here you can see the velocity of the body is not changing. It is constant throughout. With respect to time, the velocity is not varying. If it is varying, we must write like this, right? So like this, or if it is varying, we should write like this. So in this we can observe the velocity remains same throughout, and this is called as uniform velocity. So next we can observe negative velocity. Here you can observe as the time increases, the velocity is getting decreased. So it is negative velocity. So next we have positive velocity, which means as the time increases, you can observe the increase in velocity in a positive direction, and hence it is positive velocity. It is also termed as uniform acceleration. So to represent uniform acceleration also, we use the same plot. Next, increasing acceleration. You can observe change in velocity with respect to time is acceleration. Here the velocity is changing with respect to time. As the time increases, the velocity is also getting increased. So it is increasing acceleration. So we have studied about acceleration, increasing acceleration, negative acceleration. So here we can observe as the time increases or as the time changes, the velocity of the body is also changing constantly, and hence we are getting a straight line, and this is a plot of constant acceleration, which means the velocity is changing, which results in acceleration uniformly. So these are certain important and interesting concepts which helps us in understanding the expressions or the derivations of kinematic equations, which we will be discussing in the next session. So in this session we have learnt about the acceleration, average acceleration, instantaneous acceleration, and also position time graph, velocity time graph, and its various cases. In our upcoming sessions, let us discuss some more interesting concepts on motion of a body in a straight line. Until then, please take care all of you. Thank you.